Now the last set of parameters is the transmission parameters. So this is also called as ABCD parameters. It is more commonly called as ABCD parameters, to be frank. So what are the independent and the dependent variables here? The output side parameters V2 and I2. These form the independent variables. And what about the other two, V1 and I1? These are the input side. So these are the dependent parameters. So you can see here, this is a parameter that is most commonly used in power systems. It is called as transmission parameters. It is used in the analysis, transmission analysis. Power systems, we have transmission, right? So there we are going to use these parameters, and that's why it is called transmission parameters. You can see that the output side are the independent variables. In power systems, we call that as the receiving end. Okay. So you have a transmission line like this. This is the input side and this is the output side. You will have three different lines, right? Three phase lines. Now the output side is the side where the power is being received. So it is the receiving end. Input side is where the generation is happening. That is called as the sending end. Okay. But here in networks, we will simply call them as input and output port. Now here you listen one thing very carefully. This is the two-port network. We have the input and output port. What we have been taking, V1 and I1, we were taking like this. I2 was going inside. And this is V2. This is what we generally use in networks. Any textbook, any network textbook if you take, you are going to see this kind of representation. In a power systems book, it is going to be slightly different. So what is that? Like I said, the input side is now the sending end side. So here the current is entering, and the other side, this is the load side, the current will be flowing out of the two-port network. So this is a more generalized network. Okay, but this is a network which is particularly used in power systems. Okay. So this point is important here. The current is moving out in case of power systems. So you don't have to remember that it is networks and power systems. What you have to remember is the current will be flowing into the two-port network in one case. The current will be flowing out of the two-port network in one case. Now in this case, what will be the ABCD parameters? The parameters are going to be the same. Just the way we are going to represent is going to change. So in the first case, what we are going to write, V1 is equal to A V2 minus B I2. So you see the negative sign here. The input current I1 will be C V2 minus D I2. But in this case, second case, what we are going to get is V1 is equal to A V2 plus B I2, and I1 is equal to C V2 plus D I2. What will happen when you write in matrix form? V1 and I1 will be equal to, the parameters will be remaining same. What is going to change is, here it is going to be V2 and here you are going to get minus I2. Here instead you are going to get V1 I1 will be equal to ABCD V2 and plus I2. Okay. So this negative sign, here positive sign, this is the only difference here. In our discussion of networks, since we are discussing network subject, we will go ahead with this nomenclature. Remember, in both the cases, ABCD parameters are not going to change. Okay. So in this case, what will be A? A you can write as V1 by V2 when I2 is equal to 0. So what will be the units of A? It will not have any units. Then what about its name? We can call it as open circuit voltage ratio. Next, what about B? B you are going to get from the first equation as V1 by minus I2 when V2 is equal to 0. Then what will be the units here? The units will be ohms. What is it called? It will be called short circuit transfer impedance, right? Because it is V1 by minus I2. The next parameter is C. This you can get from equation 2. What will be the equation? I1 by V2 when I2 is equal to 0. So the units here are going to be mho. And what will be the parameter name? It is going to be called open circuit because the current is 0. Transfer admittance, right? Because it is the ratio of current to voltage, not voltage to ratio. Okay. Next, finally, parameter D. This is going to be I1 by minus I2 when V2 is equal to 0. So what will be the units here? This also will not have any units, and this will be called short circuit current ratio. This was the first case. What about the second case, wherein the current direction is going to be out of the port, out of the two-port network? So here A and C are not going to change. A and C are same, but you can see that B will be equal to V1 by plus I2 when V2 is equal to 0, and D will be equal to I1 by plus I2 when V2 is equal to 0. Okay, so minus sign is not here because the current direction we have taken in the reverse direction. So whenever you are writing the current in this direction, then parameters, don't forget to include negative. When current is going out, then the parameters should not have any negative sign. Okay. Now finally, the condition for reciprocity and symmetric conditions. Okay. So using the ABCD parameters, what will be the conditions? Condition for a symmetric two-port network is given by A is equal to D. Okay. And similarly, the condition for reciprocity, this is going to be AD minus BC is equal to 1. Okay. So using the transmission parameters, this is the condition for symmetric and reciprocity. Next, we have another set of transmission parameters called inverse transmission parameters. Okay. So this is also called as small t parameters. The normal transmission parameters, they are sometimes called as capital T parameters. Alright. Now what will be the equations here? Here V2 and I2 will be the dependent variable. In normal transmission parameters, V2 and I2 are the independent variables, whereas V1 and I1 are going to be independent here, just the reverse. That's why it is called inverse transmission parameters. So what will be the equations? V2 will be equal to, you are going to use small letters, A V1 minus B I1. Here also what will be the direction of current? Taking the network's condition. So that means I1 and I2 both are flowing into the two-port network. Okay. If I2 is flowing out, then as it is, accordingly you have to use the positive sign here, just like in the previous case. Then what about I2? So it's going to be CV1 minus DI1. In the matrix form, if you write V2 I2 is equal to ABCD will be as it is. The negative sign will be shown here.